Hello, everyone. Our project is no-code vision LLM. So at first, who we are. So Ninja Lab is a quite fresh, Finnish startup, and we are really small. So we originally focused on quite small thing, which is making big AI to small, and to enable the AI running on a variety of devices. And we are funded by European Space Agency, and we are trying to put the AI running on satellite. That's our thing. But this time, we try to make some really end-to-end service. And this project is LLMCAM, so which means that the AI is interacting with the camera. And recent LLM, it's multimodal, so it can communicate. It can withdraw quite many of insight from the what it can see. Like on the right side, you can see there are it can identify traffic jams, traffic accident, and some kind of criminal activities and parking spaces and waiting queue of the restaurants or any temperature or anything. And it really understands quite many things. Then that's why we thought it's going to be quite useful service can be generated. So today we are going to make 3 demos as written here, and it's already published in YouTube site as well. But now I'm passing to the link for the first use case.
So hello, for our first demo today, it will be about the parking lot monitoring.
You want to the video? Or,
Yeah, maybe the video because I think I can type that. Yeah, video. Yeah. So we have pre-recorded the scenario. Yeah, thank you. So as you can see here, that is our demo for monitoring the car parking. So first, we will give the video live link to the LLMCAM chatbot and ask it about the situation inside the video. Yeah, so as you can see here, it will provide us several information about the quantitative. So for example, we can see that there's one car in the scene and many of the street lights. And also it is also state that like there are many available parking spaces, for example, here 10. And now I will ask it more about like how, for example, like the traffic. Is it heavy now? And it says that it is not heavy, it is quite light and there's not many cars. And next thing I will ask it about like, what do you think of like how can we park here? How easy it is to park in this area? Yeah, so based on the information gathered from the live, the LLM can detect that there are not many cars and there are a lot of space and there are not many traffic either. So the parking process will quite be straightforward and easy. And that is one of our feature for LLM is the notification. So if I ask LLM to stop the notification stream and ask, for example, notify me when there are 5 or less cars in the live, then it will start monitoring the video, the link that I provided, and then when it detected that there are fewer than 5 cars, then it will send us the notification. So that would be the first demo scenario for the car parking. And now I will switch to the second demo for how to integrate the OS into LLCAM. And I will switch the mic to Nghi, who will be in charge of this demo.
Hello, my name is Guy, and I'll be demonstrating one of our use cases. So this is our actual website. It's deployed at llcam.ninja.labo.ai. And we can see from this side, we have the available tool list. And this is, again, hard-coded into our program. However, a special feature of like our service is actually to integrate new services on the fly into these available tools. So this demo is also available here. Mm, Dynamic service loading with DG traffic. And I'm going to use this as a kind of like command prompt for our actual demo here. So now I'm gonna start with asking. So I'm asking what tools can you use into the chatbot, and it's going to answer based on the available tool list right here. So it says like camera and image tools, which are demonstrated in the previous demo. And then it also have plotting tools. And here's the tools that we're going to use, which is API tools. So now I'm going to ask a kind of like tricky question. So I'm asking, based on these tools, can you tell me where there are traffic jams currently? So it says that to determine is going to capture, but to find location of traffic cameras and access traffic conditions. However, this is only usable if we have a specific camera in mind. So instead of using these kind of default tools, I will add new tools to this service. So the service that I'm integrating is DG traffic, which is a very open service with the open SBI specification. So I'm going to like copy this command right here. Um, so as you can see here, I'm providing GPT with the base URL, and then I also provide the open API specification URL, which is yes, I'm adding it back here. Yes, I send it like this, and then after a while, it's integrating. And now it says the new service has been successfully added. And you can see from this side, the available tool list has expanded. And all of these newly added tools are endpoints from DT traffic. And now I can actually use that to determine where there are traffic jams right now. Yes. So it's actually extracting, communicating with D2 traffic, and now it has extracted for us our traffic disruptions and jams. So we can actually like again use our default service in combination with this or any further services that are available from raw D2 traffic. So this is how like we can easily integrate, and the user side can also easily integrate any URL or any API services that they want to on the fly like this. Yes, and I'll go back to Lynn for the last demo. Oh yes, not exactly, but like uh, you can actually use, I think this one is, yeah. Yes. So now it's just the reason that it's not exactly the same is because we have not really implement the road into this yet. So this is just some random road in the same area, but this is actually one of our default tools. So this demonstrates that you can combine different services and tools that are integrated into this session right here with our service. Yes. So I'm going to go back to Lynn.
So thank you, Nhi, for the second demo scenario. And now I will proceed to the third one, where we will feature the ability to count objects and also plotting objects. I will use this, not this one, wait, maybe this one here. So here, this might be easier to see. So this is the live demo, live YouTube at Santa Claus Village, which is this video was recording this morning, so there were quite a lot of people. I asked GPT again to capture the situation at the village. Yeah, so now that, because this is a scene with a lot of people, so it can detect that there are quite some people. So here it says that there are 50%, and it says that there are like daylight, and also the vision is clear, but the sky is not really visible on the frame, for example. And in our default tool, there are two tools that can use to counting objects. One is the GPT, which is the default thing that the LLCAM is using. But the second thing is that the YOLO, which is a computer vision model used for object detection. So as I say that, can you show me the detection image? I'm referring to the YOLO model. And now that the LLCAM can show you the detection image of what it detected. So YOLO is not very good at detecting a crown. So GPT might be better at least say that there are like 50 people here. But if there are like spots seen like fewer people, then maybe YOLO will provide you with more accurate and like kind of like bounding boxes around objects that it detected. So now we will proceed to how LLCAM can implement the plotting feature of uh, object counting. So first, I will ask it about the images I had captured at Santa Claus Village during yesterday and today. It will show a list of image here, but there might be some kind of like alerts. So I stated again. I stated that I only want the image at Santa Claus Villages. Yep. So these things, this time is more accurate now with like 4 images of Santa Claus and still one non Santa Claus, but it's better. So now I'm asking it to plot the number of people in these images using YOLO. So it will generate a bar plot here stating the number of people in these images, which YOLO can detect. And now the second time I will ask it to use both YOLO and GPT, and it will generate a plot with 2 bar plots, one for GPT and one for YOLO to compare between how different models will perform on the same list of images. So here's our result that You can see here for the blue one is the YOLO, and for the red one, I can stop. Sorry. Here, so for the red one is the GPT. It might be a bit blurry on the screen, and the right one from my side, the blue one is the YOLO. As you can see here, YOLO will be more accurate on the scene where like there aren't that many crowd, there aren't many people. But for like a very crowded scene, like the current situation at the Santa Claus village, then GPT might have a like broader sense of view, and it can provide us with more accurate on this kind of scene. And so that will be our third demo scenario for the ability to capture live and plotting and detect object. Yes, thank you.
So then going back to the wrap up. So what we have learned from this project is kind of brutally say we can consider web development or any service development can be considered as a API mashup. So primitive APIs are already quite many places are provided, like Digitraffic. So you can use those primitive API, and web development is the mashing up those API to generate new services. That's how it should be done, has been done, like from primitive to the complicated. And now with the power of AI or large language model or GPT, this API mashup part to be done almost out of box automatically. So we don't do anything, just giving the API specification, then the rest of the service gonna be done automatically by GPT. So that's really our finding. And if we extend this idea iteratively, then what happens is what people are talking about AI agents now, like from primitive APIs are generating more complicated services. And if we iterate this kind of things enormously, then your instruction gonna be quite high level. Like this is a bit joke, but if you instruct that make this world peaceful, then the GPT will understand and it will distribute the task and it's iterate towards the really the primitive ones, and it's going to be orchestrated. So that's the world we are living in the AI agent. So really, how can I say, exponentially scalable. But there's no silver bullet. So always it comes with the challenges. So what we found is the three challenges. One is imperfection of natural language communication, because it's not programming language. There are some rooms to be misunderstood. And also the scalability of the computing resources. And if one GPT, one large language model has the millions of API, then it's easily got confused to pick up the right one. So it cannot achieve the original instructions. And also the one is the learnability. So if the instruction fails, your request fails, GPT has to be learned and customized and optimized for the next things. Those are the challenges we have to be solved to proceed with next step. Yep, that's all what we have.
Thank you so much. Let's give a round of applause. I have to say that I'm amazed how great work you've been able to produce during this short amount of time, and I know that you've been quite stressed about it too, but I have to admit that it's brilliant. Do we have any questions already in the audience or in the online? If not, then let me start by asking my own questions. So the first thing is to ask, what are your next steps? How do you see the future of this type of service now?
Yeah, actually, we quite stressed, as you said, because of the short development time, and this is not our original area, but we really enjoyed, and we quite learned a lot, many things, and also now we understand what the AI agent means to the future, and we really want to continue this project, and we are really looking for the sponsor or any project to be hosted these technologies. And this technology is not limited for anything, but could be applied for the smart city services or smart building services, and even it could be extended to the robotics as well. For example, if you think about the practical use cases, then queuing, waiting queue detection for the restaurants or public services like Kela, those kind of services, or we can identify also the safetiness of the playground. So if some kind of risky criminal people are there, then it could be even detected. So the possibility is quite enormous, and we really looking for the sponsor for this project.
Could it maybe generate even like a trend report in the future, because it can capture moment by moment? So is it also a possibility in the future?
Yeah, that's easily done, as Lynn demonstrated.
Yes, exactly. Any other use cases that you would be interested in trying out, or have you already got any requests from anyone that?
Yeah.
Not yet. Okay.
I think personally, I really want to go to the robotics with this, because the principle is exactly the same. Yeah.
Okay, that's very fascinating. Any other question from the audience? There is one.
Thank you for a good presentation. You mentioned robotics. So how far you believe currently that the edge processing of the large language models are, so we could have this local AI?
Yeah, that's exactly our competence. We started, but this time we didn't have a time to do that. But it's really the area we really want, and the situation is still a bit experimental, but the computing environment is getting better and better for energy saving perspective as well, and also the technique how to make the big AI model to smaller, that's also progressing. So I think exactly it's a time to dive into that direction.
Thank you.
Thank you. And then maybe one more question from my side. It's the same question that I presented to CADvisor too. So what are your experiences from this piloting phase that you were executing during this autumn? And is there any message that you would like to send for someone who is thinking about participating into this type of pilot in the future?
I really respect that you accept this kind of bit advanced proposal, and personally I really enjoyed, and probably they have some words.
I think I really appreciate this experience working with my team, and especially I really like this concepts of like dynamic integration and then complex as you can see, we actually do very complex operations in the background. But then when we present everything to the user, it's very simple, it's very accessible. And that's like the journey of making like those complex into like simple use case, end-to-end experience is quite a learning experience for me. And I really appreciate this opportunity.
So before working with this project, I am not very familiar with LM, but then I think that like it has a very large like potential to be integrated in many aspects of life. So as you can see here, like it can talk with people, like communicate using natural language and understanding our context and know where it can improve. So I think that is very fascinating. Now we can communicate with machines and tell it to learn more, and it can also help us to experience, like know more about the situation aside without us need to explicitly tell it to search for like things online. That is from my side.
Thank you so much. It's been a pleasure working with you all. Also, Cadvisor. I think that's a wrap from the pilot side. So I could ask Jussi to come to the stage and let's talk a bit about our future steps in Mobility Lab Helsinki. Let's give a round of applause for both of the pilots. Thank you.
Yes, really cool solutions.
Yes,
It was fun to be watching the show there. And yeah, this is the actual last event of Mobility Lab this year. And the project has been going on since 2022. And we are also approaching the end of Mobility Lab as a project, as it is